All right, subtracting polynomials. Subtracting polynomials is very similar to adding polynomials. So we must be mindful that this is the thing. We're always going to distribute our operation. So we're going to distribute the subtraction to each term of the second polynomial. Now I'm just going to put the second polynomial. We're going to collect like terms, and likely the biggest source of error is adding integers correctly. So let's look at some examples. Now, what I've underlined is we must distribute the subtraction. Let's take a look at this. Fair enough. So here's what I'm going to do. My first polynomial, I'm just going to remove the brackets. Now the second polynomial, I'm going to write it in the following way. I'm going to distribute that subtraction to every term of the second polynomial. So I need to subtract negative 5p, and then I need to subtract negative 1. Keeping in mind, one thought per line. So I have 5p plus 1 and subtract negative 5p. And if I subtract negative 5p, I'm going to add 5p. Subtracting a negative is the same as adding a positive. Now, if I subtract negative 1, it's the same as adding 1. So what have I done? I've changed a subtraction question into something that looks very similar. So I'm going to put my like terms together. So anything with the variable p raised to the power of 1, I'm going to put together. And I take a look at my constants. I have 1 plus 1. So each term is accounted for. And now I group my like terms, and I'm just going to add these. Now when I add 5p and 5p, it's really adding 5 plus 5 is 10p. Watch the integer work. 1 plus 1 is 2. So simplification, or the subtraction of those two polynomials, is 10p minus 2. If you were to take a look right at the beginning at our question, is this what you predicted would happen? So subtraction is not always straightforward. You have to be very careful about the signs. Let's do another example. So, like with addition, I just simply write that first polynomial without brackets. Now, I need to, when I subtract, I need to distribute the subtraction to each of the following, or each of the terms of the second polynomial. I need to subtract 4x. I need to subtract 3x. And I need to subtract 1. Now, notice how everything in the brackets, here, here, and here, is in fact the terms of the second polynomial. I'm going to clean up my work a bit so it looks a little bit nicer. I don't like that particularly. So what I'm going to do is I'm just going to rewrite all of my terms and consolidate my signs. So subtracting 4x, I'm just going to subtract 4x. Minus 3x, I'm going to choose to write it as 3x. Minus 1, I'm just going to write it as minus 1. Sometimes I noticed there's a mistake. This should be a square. Sometimes we do small steps that aren't very important to others, but to us, they really make a big difference in getting it right. So now I'm going to group like terms. So I see that there's terms of x squares together. Yeah, I have x and x, so that's really nice. And then I have 1 and 1. So I have the x squares together, everything x to the power of 1, and everything that's a constant together. And I'm just going to rewrite them by grouping my like terms. So negative 2x squared minus 4x squared. I've exhausted all the x squared terms. And then I have 3x minus 3x. So does it help if I cross off here? So I've included 3x, and then I've included negative 3x. And then now I have negative 1 and negative 1. So negative 1 and negative 1. So everything with an x term, x squared term, negative 2x minus 4 is negative 6x squared. If you want, you can just look at your integers. Negative 2 minus 4 is negative 6. And then 3x minus 3x is 0x. And then negative 1 minus 1 is negative 2. Now, although this is my final answer, I would probably prefer to write it as negative 6x squared minus 2. Keeping in mind that every time that we have a zero coefficient, we can omit the term. All right, nearing the end. Without much thought, I'll copy out my first polynomial. Now, with a little bit more thought, I better distribute that subtraction. A little bit trickier now. Keep in mind that I consider this to be a term and this to be a term. So when I subtract the term, they become double negatives. So 3x squared plus 3xy plus 2y squared. No thoughts yet. What I want to do is I want to clean up the signage around here. So that's minus 4x squared. Now, subtracting negative 2x squared is the same, subtracting negative 2xy is the same as adding 2xy. Subtracting negative y squared is the same as adding y squared. Are we okay? I distributed my subtraction, cleaned up the signs. The next step is I'm going to group like terms. So if I take a look, I'm going to group everything with an x squared together. Next thing I'm going to do is I'm going to group everything with an xy together. Next thing I'm going to do is I'm going to group everything with a y squared together. And there we have it. Now I have 3 easier calculations to do. 3x squared minus 4x squared is negative 1x squared. And I write negative 1x squared as negative x squared. 3xy plus 2xy is 5xy. Now take a look that I'm just adding and doing the operations on the integers, and the variables just come along with it, within the group. So 2y squared plus y squared, well, that's 2y squared plus 1y squared. Well, that's 3y squared.